Okay, hi. It's me, Lindsay Berger, and I am here to talk to you today about astrobiology and how cool it is and what it is and how it even ties into the Mars rover. Because that's been on everybody's lips lately. You know, we had the big rover landing last month, and it's already shown us a lot of cool things. So I want to show how astrobiology is not only important to us in our everyday life, as is the planet Mars. You can see by this lovely model. But also why astrobiology itself is important. So I'm going to take you through a few infographics today, and we're going to talk about why astrobiology is important to our everyday life. So the fundamental question of astrobiology is there life elsewhere? Are we alone in this great cosmic universe? And personally, I think no. I think there has to be life elsewhere. We're not that special. You know, life is very resilient, as we have seen. If you're familiar with the Jurassic Park movies, it's life finds a way. So that argument could be made for more habitats other than Earth. And I apologize, that is my pug. So obviously we have our own interstellar neighborhood right here. And for the most part, we're pretty sure there's not a whole lot exciting living things going on. There may have been living instances in the past, especially on Mars and if not Venus. So Mars is of course our big target for the future of space travel because it is not as hellscapish like as Venus is. So we can actually theoretically send people there very soon. And by very soon, I mean within a decade or two. So astrobiology is just, it's where we're making a connection between biology and physics and astronomy. Typically those two fields are wildly different. You're not going to get a lot of crossover between them until this field of astrobiology emerged and said, hey, there's a connection here. We can use physics and astronomy tools to figure out if life exists elsewhere. We can study atmospheres of faraway planets and look for signatures of life like excess oxygen or things like, or hydrogen or things like that. So astrobiology is also important because, as we all know, since the space race started, space has been a major impact in all of our lives. You can't throw a proverbial brick and not hit something that space has influenced. We have the technology we have today because of the space race and the Apollo missions and that drive to get to the moon to find new things, as well as to, beat the brushes. But we have, our cell phones today are a miracle of technology. We have healthcare that's directly ties into astrobiology, because of the current theory is that a lot of the life forms, especially if we find anything on Mars, it's going to be microbial. It's not going to be the characteristic stereotypic little green man that's sitting there going, hey, we come in peace or whatever. It's going to be either fossilized microbial life from the past, or it's going to be, current versions of an extremophile or a microbe that can exist in extreme environments. And as if anybody who's worked in the healthcare industry knows, bacteria and such are getting very resistant to our current treatments. So they're adapting to becoming their own type of extremophiles in a sense. So this is concerning. We want our drugs to work when we get sick. We don't want to go back to the medieval age where it's just like, well, say a prayer and hope you do okay. That's not what we want with our current technology. It's kind of crazy. We can send people to space, but we can die of infections that used to be treatable. So we can study extremophiles both here on Earth and elsewhere, assuming we find them, and they can help us narrow down where life came from, how we originated here on Earth, because, the study of evolution is a big topic as well, especially if you're in a more conservative state. It's not even up for discussion in some circles. So if we can have more concrete evidence of where we came from, when we came here, is the theory of panspermia correct? Did we come here from elsewhere? Did we hitch a ride as microbial original life forms on a space rock from Mars? Possibly. That's a current idea, is we came from Mars. That's why Mars is dead and now we're alive. That could be an idea. Or somewhere else. So studying how these life forms change over time and how they can adapt to extreme environments like extreme radiation, extreme heat, cold, antibiotic resistance in our case for healthcare. These are all things that are very important, especially since we're living through a pandemic. Granted, it's a viral pandemic, not a bacterial, so it's, you know, separate branch of a tree, but it's still very important that we understand where life came from, why it's so diverse, how it can change, and who knows, maybe we can even find out what's going to happen in the future. It'd be really cool. That's one thing I love about astrobiology, is it's so multifunctional. You can learn so many different things about it, or about what you're studying, just by taking into account different types of science and combining them into one field. So that, I mean, just because of those reasons alone, people should care about astrobiology, but it is a lesser known field. It's, you know, most people can rattle off, you know, physics, chemistry, things like that. You know, if you ask them, you know, what kind of topics of science would you consider to be science? They can rattle off things like that, but most people aren't going to say the words astrobiology. So it's really important that more people know about astrobiology. One, because it's just awesome, and two, because it's important. So of course, like I said, the fundamental thing about astrobiology is we're looking for life elsewhere. This is not a new concept. We've been pondering our place in the universe since before we had movies and books and things like that. This is something our ancient ancestors did. That's why we have all these mythology legends that involve the stars. People have been captivated by space for millennia. It's not a new thing. Once we had the mediums of technology developed, like the movies and stuff, we've branched out, and they were inadvertently talking about astrobiology. They just didn't call it astrobiology. If you're a fan of science fiction, you're probably familiar with all the Star Wars, Star Treks. Personally, I was raised on Stargate SG-1. These lovely people on here. I mean, you know, you're a sci-fi nerd when you consider naming your pug Teal'c after this gentleman right here who had the symbiote in his stomach. Because I was like, Teal'c is like the coolest name ever. So I almost named my pug Teal'c when I was in middle school. And then, of course, I eventually got into Star Wars and Star Trek and things like that. And all three of these are wildly different universes. You know, they have different alien species, different main characters, etc. We can get into that in a whole other discussion. But they all fundamentally interact with other life forms elsewhere in the universe. And it goes both ways. It can be good, or it can be bad. And that statement right there is true, even if we find just basic microbial life. That's still kicking, if you will. You know, we don't know the ramifications of what will happen if and when we find life. These sci-fi series have kind of poked around into the possibilities of, you know, more idealistic or less idealistic scenarios of if we find something, and how those, you know, species could be used. Like in the case of, was it a tribble in Star Trek? You know, it's got the blood that regenerates and stuff like that. So getting into astrobiology, you know, these movies can make it look all cool and like everybody's, you know, very advanced, but there could be all different types of life forms out there in the universe. The universe is so vast. By the time we could even get close to the edge of our galaxy, you know, hundreds of thousands of years will have passed. So there's no true way to predict if and when and what we will find. But the current theory, and the one that I support, is we're going to find microbial life. I think there really is a good chance on Mars. I'll talk about the Perseverance rover in a minute, but I think there's a really good chance of finding something on Mars, because Mars is a really cool terrain. It's not just this big dust ball, big dusty rock, you know, it's actually a really cool dynamic planet. So of course we've been introduced to sci-fi and astrobiology. We just didn't call it that from a young age. So in real life, astrobiology is still cool. It may not be as flashy, but when you work in a lab, you are, like, say for example, if you're studying the genetics or the epigenetics of something. So this is a figure I made for my independent study paper at the University of North Dakota. So this could apply to both microbial species, like in this case, there's microbes growing in this petri dish, or you can start with like a murine sample, or, you know, a larger animal. Basically, you're going to extract some DNA, because in this scenario, I'm assuming the DNA we find on Mars, you know, say the Perseverance rover finds something, I'm assuming it's DNA that's based very similar to ours with the same nucleotides. That's a big assumption. You know, they could be slightly different. Maybe I don't know. There's a lot of ways it could go, but for this scenario, I'm assuming it's ATGC, just to make my life easier. And also to keep this video from not being 3 hours long. So you get your sample here. Let's say we picked up some microbes. For some reason, they're still alive. You know, they've just been in dormancy. They may, spores, for example, are very, very, very resistant to desiccation and radiation and things like that. They're very, very hard to get rid of, if not impossible. So it's like when we're designing spacecraft to send into, like to send to Mars or to send, you know, do flybys of other gas giants and things like that, we have to be very, very careful, and through this process called planetary protection, about what, if anything, are we sending into space? Because we've already got we've got a ring of space junk around the Earth, just from paint chips to loose screws to a toolkit to broken satellites. You know, any alien passing by is gonna be like, that planet is junky. We don't take care of their stuff. But I digress. So we need to be careful what possible microbes we're sending into space, because we don't want to go spend all this billions of dollars to get to Mars to take a sample to realize we put it there. That would be so silly. So one way we can determine the origins of a microbial species or learn more about it is by looking at its genome, looking at its epigenetics. So you would extract the DNA from your sample. I just use a standard tube here. You can then run it in a process called polymerase chain reaction, or PCR. Sometimes we do a fancier version called qPCR, quantitative PCR, with specific primers. So areas you're testing to see if you can amplify and get more of that area, basically. So this is a breakdown of how the PCR process works. Basically, you heat the DNA, you break it in half, you stick it back together with primers, and you keep rehashing it until you get all these bunch of amplicons. And so that way you can actually like focus on one specific area, because you have a whole bunch of extra data to look at. It's copies of the same part of the genome, so it's the same part of the replica, but it's more of it, so it's more easily quantifiable and to work with, basically. From there, you can make what are called libraries. You can purify the DNA, so, you know, isolate that specific amplicon. You can visualize it on gels or tape stations, things like that. These are all very common techniques. And then from there, you can move into sequencing. So you purify this specific part of the genome, you put it into a library. So you're going to put like little bitty barcodes, essentially, on this, this part of the amplicon. And the genome sequencer, like this is an iSeq, this is a MySeq, and this I call it a minion. Some people pronounce it minion, tomato. So these sequencers go through and they read the sequences. You know, to them it's just data. You know, it's a computer. You're just telling it what to do. So it doesn't have any feelings to it. But then you can use that barcodes, essentially, and you can put it in your data set, and you can highlight where that barcode is, and you can see if there's a pattern here, whether it be methylation changes, or it can tell you key markers of, hey, this is this particular species or that particular species. So these are going to be processes that are going to happen if we were to find something on Mars. So the Mars rover is, it's got little test tubes and full backpack, you know, it's trudging along Mars, and it's going to go and collect a bunch of samples from this crater it's landed in. And it's going to then store those samples. It's not going to process them on its own, because all this entire process here theoretically could be done by a robot. Parts of it certainly can. I've seen it done, but there's always something to be said for the human touch. You know, like I said, computers and robots do what you tell them to. A human can critical think and things like that. So it's going to save these samples, and then we're going to come back, and hopefully we're going to have boots on the moon, or in this case Mars, in a decade or so, and we're going to collect those samples ourselves and hopefully run these samples on sequencers there on Mars. If not, just bring them back to Earth, where they can have a whole slew of sequencers, because there's even bigger sequencers than these two. Like these are little baby sequencers. Okay, these only cost a couple grand to run. These are nothing. They have sequencers that cost up to 30 grand to run. Okay, those things are massive, like NovaSeq and NextSeq. Those things spit out terabytes of data. And you just, say a prayer for that bioinformatician, because they're just like, have fun, it's okay. So bringing samples back would be a really awesome way to connect the two planets. Like they haven't been connected in probably millions of years. But again, planetary protection comes into play. What are we bringing back? Is it safe? So ideally, if it was me designing it, I would do some basic sequencing, the baby sequencers there on the surface with an astronaut, a scientist running it. And then we determine, hey, this isn't going to kill everyone on Earth. Yay! And then we can bring it back and do the big guns. That would be really cool. Now, I don't know when or if that would ever happen. I'm not in charge of NASA's budget. Darn. But it would be a really cool thing, because we can learn a lot about, like I said, extremophiles and how they influence our own environment here on Earth, and how they can be used in healthcare or work against healthcare, just by understanding the mechanisms of how they all work. So that'd be something really cool to look forward to in the future. So this is a question I get asked a lot. Why should we even spend money on space? Why should I give NASA money? It comes out of my taxpayer dollar, blah, 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 blah. I'm a cranky American. I don't want to pay for things I don't directly see or use. But again, space has been an integral part of our life. We just don't realize it, because not everything is NASA branded unless you're in my house. So I can understand why for the common consumer, it's a little bit frustrating, because like the average person is never going to set foot on Mars in their lifetime, not in the current generation. It's simply too expensive, too physically detrimental, things like that. It's not for the average Joe. And then you've got Senator, even just a few days ago, this is on the 21st, it's the 23rd now. So Bernie Sanders is tweeting, space is great and all, but should we really be spending our money there? Because, I don't disagree with him. We should have, better infrastructure here in American soil to take care of those who need it. And space travel can be viewed as a luxury on one hand. But on the other hand, again, we're learning a lot about microbes. We're learning a lot about sequencing and protein folding and how things adapt to new environments. We're learning a lot about our own human physiology. Like osteoporosis is something that affects, I don't remember the statistics, but a lot of older women. And osteoporosis basically gets put on steroids and sped up for astronauts who go into space, because they lose muscle mass and lose bone density. So by understanding what's happening to their bodies, we can understand what happens to people who live here on Earth who will never go into space, and help them live healthier, safer, happier lives. Because osteoporosis is nothing to mess around with. You can fall and break a hip and die. So I get where Bernie is coming from on this. At the same time, it's kind of like, did he really have to tweet that? Because he was actually tweeting in response to Elon Musk, who's also in the news lately because of he's putting together, a bunch of rockets and stuff for NASA and that. So he obviously is a big proponent of space travel, but he also has billions of dollars. The average American does not. So if you're worried about putting diapers on your child, or sending him to school, or putting food on the table, yes, space travel is the last thing on your mind. I get it. I've been there myself, So I can't disagree here. But at the same time, space is just full of wonder, and I think it gives people hope, If you look at these images from the most recent Mars rover, so this is Perseverance. These are images taken of Perseverance as it was landing. It took a selfie. That is so freaking radical. And then, of course, it gets down there. It lands safely. It takes a nice little picture here. Like, hi here, Mom, I made it. Like when when you were a kid, you had the summer camp, you check in. Of course, then you had to call collect. You couldn't send a selfie. But just looking at these pictures gives me hope for the future. because I'll admit it's been a crappy year with a pandemic and, you know, teaching online and, you know, can't see my friends. It's not fun for anybody. We've all been dealing with hardships, but I wish people could just, you know, just take this from this. Look at these beautiful images of Mars. This is Martian regolith, Martian soil under a human-made tread. And we put it there. We littered another planet, admittedly, but we put it there. And it's so cool to think about. It just kind of blows your mind, and it kind of just, it's beautiful. It's so crazy to think about that we did this. And it's not the first time we've done this. If you were to look closer at this globe here, it's covered in various landing sites: Spirit, Opportunity, Curiosity. We've sent more than one thing to Mars, just like we've sent things to the moon, and so on and so forth. So it's, if you look at it from that perspective, space is also art. People have been painting, you know, the cosmos for millennia. I even have galaxy printed clothes. Of course, that may just be my fashion sense, but I know I'm not the only one who wears them. So people find beauty in looking at telescope images. They find beauty in looking at, hopefully, in images like this. So if you want more images of galaxies and, you know, cool rocks on Mars to include in various art pieces, then you gotta appreciate space travel for what it is, which is awesome. Excuse me. So my whole takeaway here is space is awesome. Hello, I'm wearing this. I have a Mars globe. But also there's a beauty to space, and it's integral to our lives at this point. We're several decades out from the space race. You know, we've been to the moon. We're going to go back soon. We're going to go to Mars soon. It's going to continue to grow to be a part of our lives every day. There's just no getting around it. So we should embrace that astrobiology is going to grow to be an even more important part of our lives as well. So I'll just leave you with these funny comics I found on the internet. So, you know, as we're all living through a pandemic, you know, I don't know about you, but I personally sprayed like everything with Lysol wipes, Clorox wipes, whatever it is, you know, especially when it was first really, really unknown and scary. Because, you know, even astrobiology might help us eliminate some of these unknown scaries in our lives. But yeah, so you can see an alien going, oh, we sent another rover, and they're just like, I know, it's from Earth, you yucky. But again, planetary protection is a whole other argument and side story. If you're interested in talking about planetary protection, of course, comment on the video, and I'm happy to talk with you guys about that. I've studied a little bit. There's lots of different aspects that go into planetary protection, you know, the legal side, the ethical side, the scientific side, all that stuff. And I always like to joke, you know, Mars is the only planet we've just completely littered other than our own. It's not, granted, it's not as bad because we haven't put a whole bunch of, you know, billions of humans on it yet. But we have a propensity to put a lot of space junk on it. You know, we're just like, here, have another rover. Here you go, you need this. And then we take pictures of it. So it's kind of funny. So I hope you have a new appreciation for astrobiology and how important it is to your life after watching this short little video. If you have questions, of course, reach out to me. Thank you for having a little sit down with me and watching this video. And I thank you for your time.